The following is a screencast presentation done during a live tutorial workshop on Tuesday, July 28th, 2015. Okay, so we're going to record a screencast of QGIS demonstration. So in Windows, you would have a similar icon that you can attach to your launch bar. In this case, well, with Ubuntu, the launch bar is on the left. I think in Macintosh, it's on the right. In Windows, you can put it anywhere. So to launch Quantum. Now in Ubuntu, it's 2.4. Now I think the Windows version is up to 2.10 now. All right. It's just the way the versioning is working. All right, so first thing you would do when you launch Quantum is to go into plugins and launch your plugin manager. Now, if you already have received the RFDA plugin and you've copied the folder to the plugin folder as we've instructed, it should show up on your plugin menu. Here it is, RFDA. Okay? So this plugin calculates for damages. So if it's not loaded, in other words, this part is not ticked over here, then you would say install the program. Okay? And at this time, it is already installed, so you can close it. So these are all the, Abdullah, you're asking about these are all the tools that you have, all the plugins that you can add on. Okay, and there's others outside as well. That
these are built-in plugins.
These are not built-in plugins. Plugins in Quantum is often developed by the community. So
we have to search.
Yeah, there are some. There are already some. These are in the repository.
Oh,
okay. So what you see is in the repository. Our RFDA is not in the repository, so it has to be obtained by you and installed manually. Okay? But once you put it into the plugin folder, it will show up when it searches. It will search into your plugin folder and it will search in the repository. And there are places that allow you to go to other repositories as well. Okay? Now, the other programs that you need in here is the point sampling tool. I use that tool. You will be using that tool, so you should be installing the point sampling tool as well. Trying to see any other plugins that you would need. Certainly the point sampling tool. I think the rest are already built in. So that's all you need for now. Okay? RFDA and the point sampling tool. All right, so once you've selected and loaded the RFDA, you're ready to go. So if you want to launch it, then you click on the icon here. And there's your program, okay? We can cancel for now. The other option is to go to plugins. And if it's loaded, it will show up on the pull-down menu. All right, you can do it that way too. Okay, so that's the plugin side of things. On the application side, I mentioned a number of things. So first of all, project. So with Quantum, as you load and add shapefiles, you can save a project. So next time you go, you don't have to go to the layer and keep loading the shapefiles. You just load the project and all the files are there. So, but the other thing also, project properties. Okay? For example, CRS, this is called, remember I mentioned enable on the fly? So it allows you to bring it in at any projection. Okay? So you have EPSG 3776, 983 CRS, EPSG 3780. I'm trying to think. I think CSRS is the Canadian one, the updated one. The difference between these two are very small, unless you're a geodesist. We're talking about millimeters in coordinate. So it doesn't matter which one you pick. If you pick 3780, that's okay. So apply, and then okay. So now our project, oh, actually you have to go down here. 3780. Okay, you can't do it from up there. So I typed down, sorry, 3780. It is not. Oh, filter, okay. Where do I select it? Oh, okay. Now, so you can type up the number. The this is the, what do you call it? The petroleum standard. Okay. Do you know what I'm talking about? The coordinate reference system. I think the petroleum industry they survey for oil all over the world, and they wanted to have a standard system where they can share each other's maps. Okay, so they came up with a numbering system. So this 3780 is a EPSG, something to do with the petroleum standard for geodetic coordinate systems. Okay, so that's a standard number. So EPSG 3780 is the name for this projection. So we say okay. So now if I go to layer, add vector. So inside Quantum, you go they call each shapefile a layer. So we could go add vector. Then you would browse. Okay, so GIS, Drumheller. We can go to here. So these are the contours. I don't want that one. Okay, so we can look at some of theirs. So for example, floodway, okay, let's see. Zoning map. Okay, let's look at T-drum. I don't know what that, transportation maybe? Okay, so this is Drumheller. And we can zoom in. This is the downtown as an example. So if you don't like the color in Quantum, you just double click, go into style. So now it's a lighter color. So you can change colors, style. It's also called properties. So you can now examine the attributes in here. Okay, so if you right click, open attribute table. So it gives you the parcel ID. It gives you the square meter, square feet, and acres for each parcel. So that's what the town of Drumheller has put into their GIS coverage for PIDs. Okay. Now we can go layer, add another vector layer. So we can add the flood fringe and floodway. We had a discussion about this, remember? Now is the flood fringe floodway saved in what system? Geographic, I think. No. So this is where we're starting to have some fun. Yeah, it's geographic. So let's remove it. So T Drumheller is in the 3TM. If we want to add in floodway flood fringe, it says, okay, it is not, it is WGS 84. Geographic, whoops.
So you have to know what the source one is.
Normally, yeah. I'm trying to see. I go WGS 84 here. Okay. So, do you see what I did earlier? Okay. Remember we set up the project reference CRS as 3TM 114. The floodway flood fringe from the Alberta government comes in that long, geographic. When if it doesn't have a PRJ file on the shapefile, which is the projection file, it then prompts me when I bring it in, is it the project coordinates? When I said yes, then it put it out into space because the numbers were so weird. Okay? So in order to have it automatically on the fly convert lat long to 3TM, we have to actually indicate that this has a WGS 84 coordinate and that we now want to bring it in on the fly to reproject it to WGS 84, so it overlays the same map. Okay, that's what we just did. So this is why I'm saying that later on, if you start to work in different coordinate systems, it gets quite messy. Okay, because visually you think they all line up, then when you go to process something, like if I try to build a buffer now, it probably won't work. Okay, if I try to merge the two polygons into one, it won't work. Okay?
So you said you saved them both as the same?
Well, what you need to do then is you need to reproject. You save them in a new projection. So what happens here, for example, I can save them. Save as, okay? And it would say, what do you want to save that as? So this is say floodway, right? But now I want to go 3TM. TM 114, okay? But I don't want the layer CRS, sorry, cancel. I want to make sure it's the project CRS. See what I did? Instead of layer CRS, I want to save it in the project CRS as I see it right now, okay?
Yeah.
So then I go floodway, 3TM. I mean, I can say 114, I don't have to. Save. Okay. All right. Flood fringe, save as again. So instead of layer CRS, project CRS. Browse, flood fringe. TM. This is one nightmare about GIS is you end up with a gazillion files because shapefile's already 5 files. Then we save another 5 files. Okay. So now I should remove these. Now, if I import them now, floodway and flood fringe, it doesn't ask me about the projection anymore because it has a PRJ, and in the PRJ it actually has the 3TM.
So if it has a PRJ and it's got a different coordinate system, it won't ask you, but still you might not know.
It will on the fly project it. In fact, if you already have a PRJ, it's even more tricky because you don't know, it would automatically,
Yeah, so you don't know.
you don't know until you try to process some overlays or buffering.
But what
Or
if you
merging.
save the project? It doesn't save it.
No, because the project just saves pointers to the files, okay? So we have the two here. Let me bring in some more then. What other ones did they give us? Add another vector layer. Cross sections, okay. Actually, instead of this now, before I do this, let's cancel. Let's go into the folder.
Can you just zoom into that so I can see what you, so this should be, this indicates the floodway and the flood fringe, like you put that other layer on and that's the government ESRD
Yeah.
or whatever we're called.
So this is drum. Okay. So here is Drumheller, all right? Let's make it darker color.
And you just incorporated this layer that shows flood fringe and floodway.
Yeah. So this is the town, right?
Mhm.
If I turn on the floodway,
Uh-huh, okay.
it more or less follows the channel, yeah? If I turn on the flood fringe, then it goes outside the channel, okay? So I can also you can go and make it transparent so you can see through it. So you can see that it's flooded. Well, the flood fringe is this area. Yeah, but in reality, that's the 100-year flood right outside, okay? It's just the definition of the depth and velocity that river engineering have applied in Alberta, okay? To me, I mean, I hate to say it, and the other Peter isn't here. To me, this floodway Abdullah's here. Don't say anything to them, Abdullah. But this whole floodway, flood fringe thing in Alberta encourages development in the floodplain. That's the stupidest thing the government could ever do, all right? It's a floodplain. This whole thing floods. So by making this distinction, you've basically given the municipalities the ability to say, oh, it's only flood fringe, so let's build in it. But then basements get flooded, okay? Damages occur, and the taxpayer pays, okay? It's the stupidest thing. Anyway, that's my rant. Uh-oh. Anyway, so, in Ontario, we'll have this plus a bigger boundary, right? I mean, some places it's 200 year or more.
Right.
350
Is it Saskatchewan? Sorry?
BC is
200. Saskatchewan, is it not even
So yeah, where Manitoba is
Or
like
350 or something like
Yeah.
that?
So anyway,
Yeah.
I mean, 100 years is really nominal. I think
Mhm.
200 years is probably even better, okay? But anyway, this whole floodway, flood fringe thing, it just stirs up my blood every time I hear minute discussions about it. All right, so here is, okay. So the way I work normally is, again, it's like coding in C. I don't do GIS day to day, so everything's in my fingertips, okay? I tend to forget. I know I can do it. I know roughly how I do it. But unless I have notes, I'll go back to my notes, then I forget the exact steps, and I usually have to restart the process, okay? So like for example, now if I want to merge floodway and flood fringe into one polygon.
But can I just say,
Sorry.
so from a municipality's perspective, majority, all of them will have GIS type, knowledgeable GIS people, right? Or if they don't, they'll have they contract out to somebody with that.
Stantec would be happy to help them.
Just trying to get my
Yeah.
head around, because
Yeah.
obviously I know like the CV.
Okay, yeah. The point is, we are not going to, this is not going to be training, that's why it's not, this is for you guys here, okay?
Absolutely, yeah.
This is not an exercise I think the provincial government should embark on for each municipality just to get them up to speed on flood damage, to actually train them on GIS. It's their responsibility
Right, yeah.
to understand it, okay? Now, we have, the reason we're using quantum GIS is in case they say, well, it's going to cost us money, blah, 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 I don't want to buy an upgrade of ArcGIS. You say, well, you don't need to upgrade, and we're not going to pay you. You can download open source to do it, okay? And in fact, what this means is that if you have interested people in the municipality, they can actually do it, or,
Yeah.
you know.
The training for them would be just how to use the RFDA.
That
Yeah.
other,
Yeah.
yes,
Yeah.
yes. That's what I was just trying to understand this. So in terms of GIS, like there are several probably in river forecasting that would have that experience, correct, or knowledge, no?
And you have Peter to help you, right?
Yes.
Yeah.
Yeah, in our group,
Yeah.
everyone has.
We
that
don't have
experience in GIS.
anyone in our group, would we have? No.
Not really, but we work closely with the
Yeah.
Okay.
So I would say that the medium size and up, no problem.
Right.
The smaller municipalities may have a bit of a problem. Okay, they may or may not have a GIS section. They may have contractors supply them with data.
Great.
They may use SPIN, but not much else, from the provincial government. So a lot of those things would depend. Okay.
Right. We have to look at each community.
Yeah. Yeah, you got small to big, right? So in there, they're not all the same.
And what, how much is that risk? Like some might be minimal, a couple of homes, right?
Yeah. If it's a hamlet, there's nothing to do much. Yeah. So.
There's only two
Mhm.
properties.
Mhm.
Okay.
Okay. So anyway, so there's some basic functions you would do here. So for example, if I were to, in our process, we would merge these two polygons into one, the fringe and floodway and flood fringe, for example. Okay. Let's see if I remember how to do this. So it's usually under vector, and it would under topology or geometry. Let me see. Some research tools, geographic processing, merge, geometry. Merge shapefiles into one. It's under data management. So again, what I would do is I would type QGIS, merge two polygons, and I'll look for, people tell me, go click this, and that would be what you would do, okay? So in terms of, this is another one of those, if they're not in the same projection, it would burp, and you wouldn't know why, okay? So I can go, whoops, select the shapefiles to merge. Okay, cancel. Let me see now. Select layers. Okay, select by layers in folder. Okay, input directory. Where did I come? Okay, hang on. Properties. Oh, it's from Drumheller, sorry. Oh, we just go test. I need to browse. So another kink about this one here. Okay, so test. So Drumheller merge. Add result to canvas, and let's see if that works. Oh no, I think it's merged everything in the folder. So I need to put these. All right. So it's a little kinky. There might be. Now let me think. Now, I know I did this, so it's a matter of either that. I thought I was able to select the two.
Was it that used one in the folder?
It may not be. There may be another. Okay, let me just go back to geometry tools.
Now the idea of why you want to merge these layers is just so you can have a base.
Yeah, so you want to merge. You want to merge the floodway, flood fringe, and the overland flow area. Okay, inundation area into one. Okay, polygon. Then you want a buffer. So and then that's the outer bounds of your project area. Okay, so then you want to capture all the buildings inside that to make sure you got the total inventory. Okay, so that's the process. And we may not be successful here to do this, but it is a matter of I'm kind of stubborn.
Is that select by layers in the folder?
Hmm? Well, this is select my layers and folder, but I'm not selecting. So if I'm selecting polygons, let's see if it will work without that. There is actually a polygon. Save and it's going to override. Yep. I have two open files. See if it's smart enough to know there are no shape files in the directory. Okay, select another one. All right. So what it wants me to do, it's a little hokey, but again, this is like I'm saying, it's
So you have to create a directory that's like your merge directory.
yeah. So what I'm going to do now here is to do this. No, this is deck. Sorry. Okay, so flood fringe and floodway. So I'll copy these. So we browse. What the hell's going on here? So I actually have line work that's merged. Obviously I'm picking the wrong tools here. All right, anyway, it can be done. I'm not using the right app here. I'll have to look through my notes to find out what I did. Anyway, the idea is to merge them and then buffer them. Okay. I know buffer should work, so we'll show you what the buffer.
There was a union I saw. If you go back to that menu, union. Is that just measuring areas that overlap, or?
Well, you can go dissolve, but I don't know if dissolve's gonna. No, dissolve is not the right one. Well, I'll try union. Union will just.
The overlap.
We'll try union. Maybe union has worked. Okay. So what union does, union is actually combine the two into multiple polygons. Okay? Do you get what I'm saying?
So it keeps the all the attributes aligned.
Yeah, so now what you want to do is dissolve this inside, right? I'm not sure. So there's only 1, 2, 3, 3 of these. Let's see if dissolve will work. There is, I think, theoretically, we now have one, hopefully, although there's some kinks. Yep, we have one polygon now. So it's union and dissolve. Okay, if I turn on the floodway, should be inside it. Flood fringe. Okay. So using union and dissolve, I have one polygon. So the floodway and flood fringe is now one, and now I can buffer it. So if I want to go buffer, buffer distance. So I can go 75 and go 100. Let's go 100.
And is it default meters
Hmm? Yes. This is the units of your, it's a coordinate system is metric. Okay. So we're going to call this project area. So this is now, so we now have a project area which is based on a 100-meter buffer of the union of floodway and flood fringe. Okay? So then what we would do with this now, this would be the, if I zoom out, sorry. So this is our study area. So we want to make sure that we collect, if this is the project boundary, which is our 75-meter in Calgary, we want to make sure we have all the buildings inside this project area. Okay? I would rather we have used project area than the 75 meters, which
Yeah.
between Steve
Study
and
area or something.
river engineering guys, it just drives me crazy. But anyway,
And Drumheller's no normal city, it's very long.
yep.
Yeah, it's, unique.
So then what you do with this then, the next thing you bring in is you bring in, add another vector layer. So this would be the cross sections. Okay?
So you can auto extend them
I manually extend
or?
it. I mean, if you had AutoCAD, you can bring it into AutoCAD and do the 2 lines and then extend. Basically, you need to make sure you extend these out so that they clip, and then you want to make polygons out of that, right? So it's another more GIS processing so that you get all the reaches, all the zones for your flooding.
That's not the head grass.
This is the section is the HECRAS. Eh? That's the location of the HECRAS sections. So if I go look at, okay, so they have a section number. Okay, now what they don't have here is they have a report. Each section number has flood. Remember that other table that I showed you in the manual,
Yeah.
tutorial manual? So that came out of the hydraulic report. So I'll just explain to you what I had to do. Where did that go? Okay. So these are my working notes. So basically, we need to rename the cross sections, as I said. We need to convert the reaches into an XLS. Okay. We need to generate the cross sections. We need to do JTable joins. Okay. Delimited CSV, and then we eventually get that to an XLS. Okay. So what they actually gave us was information that was kind of in a report. Okay. So what I had to do is I took this and I had to convert the PDF. I had to scan it into text, take it into Excel, formatted the table so that it came out. Okay, I mean you can manually type it in or do whatever. So that's what my notes were saying. So basically, I mean every project's different. In Calgary, they gave it to us. The consultants did all this. Drumheller, the consultants didn't do this. So I have the sections. But I had to
They
now.
were sure anxious to get all the results very quickly at the end, hey, but providing you with the data and the information to
Yeah.
do it and run it was a different story.
Right. So
At the
we.
end of the day, you need an XLS file with the sections and the
Yeah.
And the average between the regions.
Yeah, and the average between the reaches. And you make sure the numbering, there's decimals here, like I said. I can't handle decimals, it has to be integers, so I turned those into 1013.
As long as they're unique.
As long as they're unique, yeah, and you don't have duplicates. And they had duplicates, eh? They had 7 repeated because 7 was a tributary to Rosebud Creek was 7 and the Red Deer was 7.
So we need a provincial system where
Well,
everything
it doesn't matter, I guess River Engineering will have to give, so every runs have to be unique cross sections in the project, but you can work around it, all right? So we took those, converted them to spreadsheets, and then merged them. And then I had to do it twice because they had natural and regulated. Okay? So out of all that, then basically you can see that the result was okay. Now,
sorry, the locations of those lines, because if this GIS layer comes from the table, the locations, was that from that distance column, or
sorry?
how did you get the location of each ridge from that table?
Get the location. Well, this tells me which cross section corresponds to
Okay,
that.
so you got that, that's another input, it doesn't come from the
Yeah,
table.
the GIS in their case, the GIS only had the section number here. Okay.
Okay, and so that you were getting the elevation.
Yeah. So what I needed to do was make sure that their table, it would have been nice in a spreadsheet, but if it wasn't, then I still had to scan and convert it to a spreadsheet. And then I had to take that row, make sure it matched this row, right?
Right. Okay, but they did provide this GIS.
They just
Without
provided
elevation.
the location, yeah. Yeah, in 2D. Okay? And then you had to take the 2 and I had to get the program to write the average. Okay? Between 1 and 2. 2 and 3. Okay? So a little bit of crunching when you produce it, but you only have to technically do it one time for one hydraulic cycle. Yeah? And so, oops. All right, so that's the process, and then from there you would then bring in the other thing you would bring in. I believe, hopefully this is the buildings. There we go.
To run the model, technically all you need is the point, right?
Yeah.
The center.
Well, we need the buildings because these are just lines, I think. Let me zoom in. All right, let me turn off the project area. Oh, yeah. Okay. Well, this is the other complication. They gave us lines. These are not polygons. I guess, I don't know if the other one is polygon. Let me see.
Yeah, I can't remember.
Is that LOS?
But ultimately, it's putting that ID point in the middle of whether it's a line or a polygon.
Yeah, but you need the polygon so you can get area. Okay, that's LOS. Let's try the other one. BOC. Okay, BOC is good. So BOC is the, okay, so BOC is the building. And each building has an area already. They compute it. Okay? And they give us the centroid, the PID, the centroid, and the XY. So we just need to now expand this one.
Now you'll notice there's nothing in there that links it to the inventory thus far, because the assessment records don't have property IDs.
Yeah. So this is the other issue. The assessors have assessment roll numbers, and the roll numbers are not tied to the PID.
They could, I mean, there's
So-
no reason for it.
How do you all just convert it to a coordinate then, or?
This addressing in terms of like 23 Main Street isn't that easy because it's often recorded in different cells or different ways, or yeah, there's no way to process it that way. There's how many of you that you want to say get the manual now?
I'm sure quite a few thousand.
Yeah. Sometimes it's there. I think on one she was able to write a program that would grab the. She could tell that the nearest.
Yeah, because
coordinate
yeah, the physically the only thing they would have is a street address, right?
Yeah.
And if that's wrong, then
Yeah. It all depends on the data you have. Like sometimes we can tell that an address, like 23 Main Street, was used in the same way every time. Like it was hard coded somewhere. Other times, assessors write it in different ways. It's in different fields, parse it, or whatever else. So it all depends on your data sets.
yeah. So the issue is again, you know, like if you talk to municipalities, Heather, and you know, the recommendation is that the assessors, the GIS people need to work together. Like City of Edmonton, actually, it was very proud many years ago of. They have one database which actually links all the different tables. Okay, so they have addressing, PID. Okay. And basically, so it doesn't matter which way you go, you can always grab from one department and say this corresponds to this. Okay, and Carrier doesn't have that.
And that's a risk with the smaller ones. So they say, oh, we outsource our assessment. So can you do this? Yes. Something comes up. They just do it by their system. Nothing to do with whatever else is going on. It's probably
Right.
So if they can add, you know, something there like a PID and roll number, or doesn't matter where that table comes from, as long as somebody has it somewhere, that we can do the lookups, right? But somebody has to say this PID is this roll, or these rolls. It'd be more than one roll possibly per PID, because
And even better would be the improvement of single-family dwelling or whatever. If it's a separate assessment record, it should have a building ID rather than parcel ID, because they're all records, right? But as it is now, they've all got the same roll number, and that's it.
do they have in the assessment building IDs?
I don't think so. I only have Fort Mac. I only grabbed Fort Mac. I know they just have roll number. I think they don't know. They don't have building ID.
Yeah, so, I mean, in this process, Heather and Peter, is when we do this, every municipality has some different quirks. I mean, we're trying to get the same point, but they do have different
But that's
quirks.
certainly another one of those labor intensive things. Linking.
But it is a one-off. I mean, they only ever do it once. It's
Yeah.
digital. So, I mean, it's not
Yeah, because it depends how many buildings you have.
it's not rocket science, right? I mean, the two big ones, they got it under control, right? Now the small ones then. But anyway, So what we try to do then is to take this, okay, this attribute, and generate points, and then link the other attributes from the assessor's data to create the database. Yeah? Now I don't know. Let me just save as tutorial 1. I keep coming back to RFDA, I don't know why. So I'm going to do a new one. Let's see what happens here. Actually, I don't want to bring it all in. It'd be kind of messy. So, okay. So what did I do then? So, Heather, that's the exercise I've done. I've taken those, did the buffering, took the cross sections, did the work on them, and basically here now we have the Drumheller reaches. Okay, and if I examine the Drumheller reaches, you'll see the start and end. So each one of those correspond to hydraulic section. Okay. Now, ultimately, what is this one? Let's just see. No, this is the flood merged. Here's Drumheller cross section. Heck, okay. When I worked through it earlier on, so you can see here we took that, the cross sections only had basically the section number up to the section number column before. All right. So then I've taken the table and I have appended or joined based on the section. Okay. You see what I did?
How do you do that? Add data.
A join.
Okay, so you can just join in a select the Excel spreadsheet.
Yeah, you take the Excel. Well, you may have to be a CSV. I can't remember, but it's XLS or CSV join. Or you can take it out in spreadsheet and you can always do it manually if you can't automate. All right, so that's how we did the hex sections, okay? And then from there we actually then come up with, it is a program to actually generate the other file. And I don't think that is a yeah, this is just GIS stuff. So the flood table, or Drumheller, is a spreadsheet. So basically I had to take this section, say 81, from the cross-section with the flows in section 82, average them, and then populate this spreadsheet. Okay? You had to do a number of lookups, and if you write a program or a script. Okay? So then this is actually then the flood table. So out of those exercises, then you get to this table. This becomes the natural one. Then we had to repeat it for regulated. So for Drumheller, we actually had to do 2 sets of flood elevations, regulated and natural. Okay? And then ultimately, what happens with this other work on the GIS stuff, we ended up with this residential data, as you can see. Okay, so remember the fields that we say you didn't need to have? So those are in Drumheller, they're blank. So in Drumheller, instead of the PID number, we use the roll number. Which is this column here. Okay? So whatever you need, and there's an address. So I think Melinda probably did some juggling, right, with addressing. And
Yeah.
okay, and then here you have the classification is the C's, and then the type is the D, the other one, the second column. Okay, then the area assessed, we didn't use the assessed area, but we're using GIS area. Okay, and then the total scale factor is 1. It didn't change anything on the total. But the content is actually less than Calgary. So it's 98%. But structure is slightly higher. Okay, and then for basements, we have yes. Okay. So then we have the coordinates. So then we're using 0.6, 1.2 seems to be. Some of those must be. They're pretty high there, eh? Whatever the.
1.2 would be a split entry, and the assessments were actually pretty good at determining like, the housing structure. So split entry, what we did was we bring it up. It's essentially a bond. We'd give it a what is it, a D? Probably DA or yeah, and so it's essentially a bundle of just up in the air. Right? So you walk in, you can stairs down, stairs up. So that's that. So that would have been explain the 1.2 height on the first floor. And then it would be basement, no. Yeah.
Some left grid,
Basement, yeah. Oh, yeah. Sorry, it would be the basement. Yes, the ones that
it's like a half basement kind of thing.
split entry is full basement, raised up. Yeah. So it is a bungalow. Yeah. The one that split level. Oh, exactly.
And then so you have from 2 cross sections. And then the last column, which is column 27, is the draped elevation on the DEM. So we take that coordinate point, the XY, drape it on the DEM. So again, the DEM has to be the same projection. So normally it's very hard to reproject the DEM the surface. So if you had to, you would change the coordinates of the points to fit the DEM, and then drape it. But the two have to be the same. And after that, you can always reproject the points. Rather than, what's the word? Okay, normally, a lot of times, the LiDAR surfaces, the DEM geotips, are in UTM coordinates. And provincially, the municipal coordinate system is 3TM, so they don't fit. So it's actually easier to take the...
You have a program that converts it over?
Well, that there is, but then obviously you would degrade the DEM, right? Because the raw data is in UTM. So it's easier to move the points, drape it, and then move it back. Because all you're doing is you're sampling the elevation of the location, right? So, yeah, you're always in GIS struggling with coordinate systems. It's universal. So in that case, I would recommend moving the points over.
Because then all you're getting is the difference.
No, you just want to get the elevation. You can always go back, right? Because all you're saying is, what's the elevation here? Okay, so this is how we would assemble. So what we call munging from assessor's data, GIS data.
What do you call it?
Munging, M-U-N-G-I-N-G. New term I learned.
That allows someone to become a munger.
Yeah, that is usually Melinda. Is the munger.
Legal and Scrabble.
Okay, so then so we have basically in the process we have now generated the hydraulic file, the inventory file, right? And then damage curve. So okay, let's look at the damage curve file. So David can so this is the commercial damage file. This is just ComDem, sorry. I want the combined one. Okay. I have so many folders. Okay. So here we go. We have, here is the damage tables. So we have a total of 70 individual curves. So we basically have 5 commercial structural, S1 to S5. Okay, the highlighting that you see on my tables will be when I'm doing QA or checking for bug errors, okay? So I have to try to figure out why I'm not getting some numbers. So S1 to S5, A1 to N2 is commercial. Okay, and then we go into residential. So you can see the residential, there's groups of 4. content structure, main content structure, basement. Now we do not have a B-type split level, right? We no longer have B.
No, C is the split level.
Oh, C is
Yeah.
A, C, and D.
We didn't have splits for calculus.
Okay.
And so C is the split level.
So at the bottom here we have essentially mobile homes, the Ds do not have basements, but I've added them in just,
Well, and there's, in Drumheller, for example, there's a bunch of mobile homes on full foundation. Windows, and like they're full foundation. So they're not Ds anymore. They become Bs or Cs depending on the size and quality. Most likely a C in terms of quality. So using these classifications and the tools like height and that from on the inventory is not about being just saying something, you know, put the height down on all these main floors. It's understanding how the curve and that works together. Right? So that's one of the key things I think is whoever's doing the inventory has to know what these damage curves represent and what putting them in the values in the inventory does. You know what I mean? So you may classify a mobile home as a C.
okay. I've added those in. There's, like basically 6 of those are redundant because there is never any basement for those type of structures. But I put them in as part of error trapping. And in general, what will happen is if we have entered a classification that doesn't exist, the program won't stop. It'll just go to the bottom and it will generate 0 damages. If you encoded the class and type wrong, okay, residential, or class and type wrong in commercial, it will just default to 0. Okay? So it won't give you an erroneous number, it just won't. The building will have no damages. So this is the kind of structure, and if you go across, and so they have various sizes, and it's all flexible as to how long or short they have to be. Okay? So we have everything then. We have the damages, damage curves, theoretically. We can actually do a test run. Okay? We'll wait for Heather to get back.
Quiver.
Excitement builds.
Finally. God, it's like an 8-month process just to get the data right.
Oh,
A rapid flood damage assessment. You can do it quickly. You just got to do it 24 hours a day.
and this is rapid. Believe me. Okay, so we're going to do a run now. So let's try a run. Oops, it barfed on me. Errors occurred, close, cancel. All right, let's shut her down. Restart. It obviously didn't like me jumping around. Okay, so we can run our RFDA without having to load any GIS layers, so we can just start. All right, so we'll select. So you have an option. Unfortunately, it's a little clunky. This thing, for some reason, I can move it. Okay. No. Technically, I should be smarter than this and make it so that I don't have to. So let's do residential. Okay, flood elevation. Let's do regulated. Damage curve. Parameter file. So this is residential. So where's my res par? Oops. Oh. Okay, and then output. Okay, so okay. Oh, sorry, save. Okay. Now, as I was saying earlier, this thing doesn't, I don't have a progress bar, just doesn't want to work. So it grays out like that. That means it's working, it's actually good. It's the, if it goes gray, it's crunching. Now, I don't know how many records, I think quite a few, so it's going to be doing all kinds of searching and calculating and then searching and calculating. So it's doing, I don't know how many thousand records, and it's doing it for 8 flood events per record. So each one it's processing. Okay. So while it's doing that, I'm going to just terminate my video, and the results should be all good. So when the program is complete, you will see the pop-up dialog that the calculations are complete. So to finish off, you click OK, and then you can shut down Quantum, or you can carry on. So let's minimize it and go and open the output file. So the output file is a CSV file, comma delimited file. So when you open it with LibreOffice, you can basically import it as into a spreadsheet format. So this is the results here. I would recommend that you basically cut and paste, so you'd have each storm event, like 2-year. We scroll down. We have the 5-year and so on, whatever number of frequencies you have. Okay. In the order, basically the first column is just a count. So what we have is basically about 1,400 records. The second is the ID. This is the first, the third column is the contents damage for the main floor, structural damage for the main floor, contents damage for the basement, structural damage for the basement. So we would recommend that you format these by cutting and pasting them, each frequency side by each. As an example, and save them as a Excel. This next step is an example of post-processing, how we would get information to calculate average annual damages using the comma delimited CSV file that was output from RFDA. So double click, import the data into a spreadsheet. Okay. Now we can manipulate this by separating out each flood. For example, this is the 2-year flood. Okay, we can cut and paste the 5-year flood. And save it. And paste it beside it. Similarly, select a 10-year flood. I'm using the keystrokes for shortcut for LibreOffice LibreCalc. All right, it's slightly different in Excel, but you can do the same functions once you're familiar with it. I will move on to pause and carry on so that we don't have to watch me do this. So once I've completed cutting and pasting the different frequencies together, and go back to the first one, in LibreCalc is Control-Shift down arrow, brings me to the bottom. So now I want to sum, create a sum, so Control-C, copy across, sorry, Control-V, okay, and then I want to sum this across here. So now what I have is I have a summation of each of the different flood damages, main contents, main structure, basement contents, basement structure, and then a summation of the total down here. Okay, so this is one set, and this is the sum total. Okay, so I can just cut and paste this, Control-C, Control-V, Control-V, across. Oops, made a mistake. I'll pause and fix this. Okay, I fixed my mistake. I copied it in the wrong columns, but anyway, now this is all corrected here. So we have, in essence, the entire up to 1,000 years. So what I will do is I will copy the totals into an array. So Control-C, come back here, and let's just paste it down here, Control. Okay, so this is paste special, place only, number. Okay. Next one, copy, paste only, number. Copy, paste only, number. Copy, paste only, number, copy, okay, so what I've done is I've completed copying the total damages for each return flood in years, like 1,500 down to the 2-year here. In this column, and then I've calculated the probability, so it's 1 over 1,000 on this axis, on this column. So now I can actually plot using the graphing function. Select the scatter line only, okay, and I can finish. So in this case now, this is your probability damage curve as per the flood frequencies we've run for this condition in Drumheller. You would then take this curve and actually do some more processing to generate the average annual damages. Okay, actually this is reversed axes, so I'll have to change the x's around. So we actually have damages here and probability here. We want it the other way around. So let's delete this and try again. Sorry. Okay. So we'll go graph. Scatter that one. Data range, data series. Okay. So we really want to flip these. Okay, probably the easier ones cancel. Easier is just to copy this over and plot this axis. So we'll go graph now. I want to reverse the location. I want to also plot the grid. All right, so there you go. This is better. So you need to, in order to get the dollars here, it's got to be in this column, probability. It's, and then I would save this and undertake some more analysis to determine where we want to truncate these axes. In general, we would consider that you will not get sewer backup until the river exceeds the bank, which is around the 1 to 10 year. So what we would want to do is probably delete the damages up to the 10 year. Okay, so the graph would change to this. So the graph axes will all alter, and this is what we want to use to calculate average annual damages. Yeah, we forgot one more thing. Before we end, we should actually save this as an XLS file. So what you need to do is File, Save As, make sure this is an XLS file. I've already done that, but just to make sure, you would say yes, okay? That would be the completion.